Hi, I'm Shamir,
And I'm Nina.
and this is Jane. Jane, like many of us, is an undergraduate student who will be graduating soon. And again, like many of us, she has never tried her hand at 3D modeling. However, she would now like to because she will soon be entering a field in which 3D modeling plays a pretty significant role, the architecture industry. Wait, no. Maybe it was actually the gaming industry. Or maybe it was the healthcare industry. Honestly, it could be any single one of these industries listed here because 3D modeling has such a wide market that it is used in literally each and every one of these industries. Jane decides to try her hand at modeling something she thinks should be relatively simple, a bottle, and so she downloads Maya, a pretty well-known 3D modeling software, and upon opening it, this is what she sees. Immediately, Jane begins to feel overwhelmed because there are so many buttons and menus and options and panels, and she has no idea where to even begin. So, like many of us would do, she decides to do a quick Google search for some tips and tricks on how to start her 3D modeling journey. But unfortunately, she's met with a plethora of results of people complaining about how hard 3D modeling is, how time consuming it is, how frustrating it is, and it's safe to say that at this point, Jane is feeling pretty discouraged. But that is where we come in. Our product, ScaffoldMerge, aims to make 3D modeling more accessible by utilizing simpler tools and crowdsourcing.
The simpler tools that we're discussing here are scaffolds. Scaffolds are a relatively new way of going about the 3D modeling process, whereby a user will recreate 3D models by drawing outlines over already existing structures. You can kind of think of this of if you're in real life and you want to make a normal drawing, you can either trace over an existing drawing or you can completely freehand that. And scaffolds are like tracing over something that's already there. Scaffolds consist of two main components, control shapes and control points. Control shapes are the outline of the shape. Here they are the rectangles, the bottom one being highlighted in red, and control points are the actual data points of the file, and here they are the gray spheres. So in order to better understand scaffolds and how they work, we're going to go through the graphics pipeline and how they fit into that. So if you have a real-world object that you want to make a 3D model of, the first thing that you're going to do is take a 3D scan of that object, and that will be read into your computer as a point cloud. Now, we as humans looking at this image can tell that is a rabbit's head, but your computer doesn't know that, and it doesn't know how to interpret these data points. So the solution is that you need a human to come in and draw a scaffold over that point cloud. Once the point cloud is taken away, you're then left with just your scaffold, which again can be thought of as 2D control shapes that represent your 3D object. What your computer will do next is it'll extrude that scaffold in order to create a polygonal mesh, which is a collection of edges, faces, and connecting points that make up a contiguous 3D object that your computer can then interact with. And once that's filled in, this is what you're left with, and this is kind of what everyone conceptually thinks of as an actual 3D object that a user would use.
The other major component of ScaffoldMerge that was mentioned earlier is crowdsourcing, which refers to the collection of input or data from a relatively large group of people, typically via the internet. And what ScaffoldMerge crowdsources is scaffolds. ScaffoldMerge allows a user to input a variety of scaffolds created by different users for the same real-world object, and ScaffoldMerge will then merge these scaffolds into a single mean ideal scaffold, which will be an accurate representation of that real-world object. Now, you might be wondering, well, how do you know that this merged scaffold will be an accurate representation? Well, this idea stems from a principle called the wisdom of crowds, whereby, given a large crowd, the accuracy and agreement typically found within the larger majority will make up for any errors or disagreement that might be found in the smaller minority.
At its foundation, our algorithm will compare common attributes of geometry that it finds between various scaffolds in order to determine how to best merge those scaffolds together. So in this example, we can see that 2 points are highlighted within these L shapes, and these points serve very similar functions of geometry for these 2 shapes. So our algorithm will go through, it'll recognize that these 2 points are corresponding and should be merged together, and will then merge them together for the final product. And now when looking at our scaffolds, there are 6 different technical complexities or things that go into merging the scaffolds. The first is the position of the points, so where the points are actually physically located in the XY plane. Second, there's the position of the shapes. So here we have 2 bottles that are virtually the same, except one is more smushed in the Z direction than the other. Then we have the different number of points. So here we have an example where one scaffold has 4 control points and the other has 8, but our algorithm still needs to be able to merge those 2 together. Now, since our algorithm mainly functions as point merging, what our algorithm is going to do is going to look at the scaffold that has the less number of points and is going to actually add extra points to that file so that it can be more effectively merged with the one that has greater number of points. Then we have different numbers of shapes, and this functions the exact same way as a different number of points. It's just doing the same thing with the control shapes. Then we come across the problem or technical challenge where we might have 2 scaffolds that look very similar to each other and functionally are the same shape, but they're rotated in different ways. So here our algorithm has to be able to go through and understand that these 2 shapes are very similar and just decide which points need to be merged with each other, and it'll do that by going through and comparing the angles of these shapes. And then finally we have transforms, so the planes of our shape can be skewed in different ways in the way they're oriented, and so our algorithm will go through and it will interpolate the transformation matrices of these planes in order to align them best with each other. So now we have an example of bringing all of these things together, and the main thing that I want to point out about this class of examples is the rectangular one in the top row of the screen, where you can see that it has a lot of weird jagged edges and kind of weird things pointing out, and we can see that part of this is reflected in the merge scaffold, where some of those planes aren't looking exactly perfect. However, they're much more smoothed out than they are in that original one, and that is showing that the wisdom of crowds is accounting for that.
In Jane's case, she decided not to let her earlier search results discourage her from doing her 3D modeling journey. And so she eventually discovered ScaffoldMerge, downloaded it. She was able to obtain 6 scaffold representing bottles. She loaded them up into ScaffoldMerge and was able to generate the merge scaffold that we see here in the bottom left corner of the screen. And we can see that although some of the individual scaffolds have characteristics that are unideal, for example, one of the scaffolds is very short and wide, another is very tall and narrow, the final merge scaffold does not have these characteristics due to the wisdom of crowds, because the majority of the scaffolds do not contain these unideal characteristics, and so they were canceled out within the merge scaffold. Now that Jane was able to obtain her merge scaffold, she can then generate the corresponding polygonal mesh, which she can then do whatever she would like with. She can 3D print it or, for example, upload it to a 3D modeling database for others to use. Now we can see that Jane is a lot happier than when we had seen her earlier, and this is because she was able to easily and quickly create her 3D model, all thanks to ScaffoldMerge. And if any of you would like to start your own journey into the 3D modeling world, ScaffoldMerge can definitely help you too. Thank you.